Okay, welcome. So I didn't see the response when Donna asked the question. How many people before today had heard of StreamSets? Okay, a few. And how many were using it? Awesome. So I'm Pat Patterson. I'm actually the community champion for StreamSets. So I look after our open source community, make sure people are getting their questions answered, and so on. You can hit me up on Twitter at Metadaddy. Come by the booth and I'll explain why I am Metadaddy. And if you still use email, pat@streamsets.com. Now, before I really get started, I have to give credit here to Harry Sridharan. He's really the brains behind the technology I'll be describing this morning. He's been at StreamSets for about 18 months now. And he's used to be at Cloudera, where he worked on Flume, Scoop. In fact, he was the PMC chair for Flume, and also a contributor to Spark, particularly in putting Spark on Yarn and the security aspects there. So with Flume and Scoop, he's worked on what we might consider the previous generation of ingest technology. So he also wrote the book on Flume. So like Ted Malaska, he's an O'Reilly author. Harry is tucked up warm in bed in San Jose right now, probably still in bed. So you can bother him on Twitter with HarrySR1234. He knows the deep technical aspects of what I'm going to talk about. I'm more the fluffy skating across the top. So who is StreamSets? We were founded about 3 years ago, and our co-founders worked at Informatica and Cloudera. And at those companies, they realized that the previous generation of ETL tools didn't really work well in the worlds of big data and continuous streaming. So they founded this company along with people from Apache. I came from Salesforce. I was a developer evangelist at Salesforce, Elastic, Square, and so on. And we now have customers across many, many verticals. So we have, in fact, I think 4 of them were nominated in Cloudera's Data Impact Awards. So we have RingCentral in communications. We have Western Union in financial services, GlaxoSmithKline in pharma, Cox Automotive, the parent company of Auto Trader and Kelley Blue Book, as well as about 25 other automotive websites in the automotive space. So really customers across the gamut, and we partner with the big names in big data and also the cloud. As I mentioned, Harry was and remains an Apache committer. We've got many Apache committers and PMC chairs in our staff. And in fact, StreamSets Data Collector, that I'll be talking a little bit about, is Apache 2 licensed open source. So everything I show you and everything our customer did, you can download the product and get to work. So just setting a bit of context, I don't want this to turn into a pitch, but StreamSets Data Collector is a way of designing and running data flow pipelines. Okay, it's a web-based tool with a Java backend, and you can build these pipelines so that you can basically factor out a lot of the routine operation of ingest out of code. So you literally drag boxes into place and configure these pipeline stages to get something working. So you get a lot of control over your data pipelines. They're really just JSON files that get saved to disk. So you can version control them, you can roll back, and everything runs in memory, okay? Drilling down a little bit deeper. So here we have a pipeline. We're reading from Kafka. It's always one of our favorite data sources or destinations. And what happens is, as the data is read off the wire with Kafka, or read off the disk if you're just processing local files, it's read into memory, and then all of these transformations take place in memory. So it's very efficient. So what we're doing here is we may be reading some hierarchical data out of Kafka. Maybe there's some structure in the record there. We're flattening out those fields. Maybe we want to write it to a relational database, something that doesn't like that structure. And then we're looking into the data with a stream selector. We're maybe evaluating some expression to either send data to Google Bigtable or Elasticsearch, or mask some fields and then send it out to Hadoop. And a key aspect here is, as well as processing data in this pipeline, we can process events. So if you see the Hadoop on the bottom right, it's got the E symbol at the bottom. What we're doing here is taking the file close event from Hadoop. So we're writing files to Hadoop. Okay, every time one closes, we want to let Impala know. Okay, if you've used Impala, Hive and Impala, you'll know you can write data into the Hadoop file system, and you can write it all day long, and you can go query in Hive, and you can see your nice new records. And if you look in Impala, it's like, where did my data go? You have to tell Impala to refresh its metadata and reread those files. So that's what you can do with this event. Every time you close a file in Hadoop, you can say invalidate metadata or refresh table, and it's very efficient at getting your data visible as quickly as possible. So that's kind of a high-level view of data collector, and we'll go a little bit deeper after we've done the use case. So this is a customer. It's actually a joint customer that we have with Databricks. It's, let's see, a major provider of shopping malls. Okay, they've got many shopping malls in the US and worldwide. And in fact, they have 2 in San Jose, where I live. And as you can imagine, there's hundreds or thousands of shoppers in every center at each time. And there's potentially a lot of data available about each shopper. Clearly, you have the shopper's current location. You have their profile, how much time they've spent in this mall and other malls, which stores they like to be in. And you also potentially have information about the applications on their phone. Okay, whether they installed the shopping mall app that tells them where the stores are, whether they've installed any of the actual stores applications. So how can our retail giant, that'll be my code name, use this data to better provide a personalized experience to their shoppers, and also get some business value out of this data? So they're using sensors. This is essentially an IoT use case at its root. So around the center track of the mall, they have Wi-Fi. Okay, many malls have their own Wi-Fi network. They also have Bluetooth beacons. And in some cases, malls are so big that, you know, without some additional help, you go to the mall, your cell phone would not work very well. There's a lot of concrete and steel between you and the cell phone tower. So just like those little femtocells, I think, you can get from AT&T and run in your house, they essentially have microcells within the mall to provide cell phone coverage. So they've potentially got cell phone data as well. So there are a lot of ways of identifying and tracking customers. So in practice, what happens is, even if you don't connect to the shopping mall network, your phone is doing little partial handshakes just to see what networks are out there. And this means that the Wi-Fi network can get an identifier for each device that's doing a handshake. And if we have multiple networks, multiple sensor types, we can triangulate to get an approximate location of the shopper. Okay, we're not interested in pinpointing the shopper and, you know, landing a drone on their head. We just want to know their general movement around the mall. And I meant like just one of those little 4-rotor drones, nothing really sinister. So this foot traffic is incredibly useful to the retail giant. You can imagine that knowing the foot traffic around the mall, we can get insights into areas that might not be signed very well. There might not be, you might need signage to drive shoppers around the entire mall. You might be able to have differential pricing for advertising based on footfall. You might be able to have differential pricing for store location based on the number of people who are going to be walking past, and you can back this up with data. Now, we can track users not only in real time, but across time as well. We can get an idea of shoppers' habits. Do they have particular routes they follow? Do they have particular favorite stores? We can calculate the time they're spending in different stores, and so on. And the applications that they use can provide additional information. So if they're using, say, the Home Depot loyalty application, we can know they're a Home Depot customer, and actually we can, if they're using, say, the shopping mall application and typing in, you know, where's Starbucks or whatever, we can get information from that as well. So we can start sending promotions and updates for recurring visits. So not only when the user passes a store, when the user arrives at the mall, they can get a notification to say, hey, here's a coupon for 10% off at, I don't know, Bath & Body Works. Always seem to have Bath & Body Works coupons. So they get the data from these sensors, and these sensors are not high-powered computing devices, okay? They tend to be very lightweight, low power, run on batteries sometimes, and they use a bunch of special purpose protocols. So we see CoAP, which is like a very lightweight equivalent of HTTP that's used in the device world. Some devices will talk like actually have an HTTP stack. Some will just talk raw TCP. Some will just fire UDP packets and forget about it, and so on. There's a whole range of protocols that these devices speak, and this is where the retail giant came to StreamSets, because Data Collector provides a way of talking to all of these origins, and in a way that they can add nodes and scale up regardless of whether they're working on a single cloud or multiple clouds, on-premise, or even mixing it all together. So the other nice thing of their usage of StreamSets is that StreamSets can work with a variety of data formats. Okay, if you recall that slide, I was reading data from Kafka. That might have been JSON. It might have been delimited, comma delimited data. It could have been protobufs. And what happens is that StreamSets decodes that into an abstract in-memory format at the beginning of the data pipeline. And from that point on, all of the processors can work with each other. It's like plugging Lego bricks together. So you can abstract away these differences, the differences between devices and protocols, completely away from your actual analysis code and your transformations. So we can read records in, we can write out, again, in any format, because we've read into this abstract in-memory representation where we've just got records and fields. And as we write them out, if we're writing out to another Kafka queue, we might write them in JSON, and we might even use Confluent Schema Registry to register a schema and write them in Avro. Or if we're writing them to Hadoop, it might be comma-separated data. And if you want the ultimate performance and you don't need to do a bunch of transformation of data, we can even just ingest a packet of bytes and just send that on. So if you're mediating, say, between MQTT, so an IoT message queue transport, and Kafka, and you don't really need to know what's in the payload, you can literally just hand the data across the protocols without parsing it at all. All right, so we read the data in, we parse it into this in-memory format, and we process it using these processors. So this is where you can do the one-time processing, okay? The purpose of StreamSets, let me make clear, is not to perform analysis in itself. It's an ingest tool. It's to get the data where it needs for that analysis to take place. But it's a great place to do one-time operations. So filtering data, enriching data, we can look up, we can use keys to look up values from, say, Redis or a relational database. We can perform calculations, do simple expression evaluation within a record. So maybe you've got some 3 numeric fields and you need the sum, and you just need to do that. Oh, well, a good one I did once, actually. I read in every city lot in San Francisco. Okay, there's a public database of San Francisco city lots, and each record has the perimeter of that lot, the actual GPS coordinates of the polygon that defines that city lot for tax purposes. So what I did was I wrote a processor in JavaScript that there's a standard calculation to take those coordinates and produce the area in square meters. I don't know, acres or something would be the customary unit. So, and this isn't going to change, okay? You read in the plot and its perimeter doesn't change over time. So this is a perfect use case for making a calculation once on the way into the analysis system, on the way into Hadoop, or wherever you're putting your data, and you get it out of the way, and then you don't have to recalculate the area on the plots again and again and again. And you can think of these processors as simple map operations on individual records. They essentially work record by record. Now, you can get more complex. Like I said, you can write processes in JavaScript, also Python and Groovy. You can even get down with our Java SDK if you want like really good performance, and work across batches. So you could do things like every 3 records you read in, you pass 1 record on, or even break out data. So you read in 1 record, and there's actually 3 records worth of data there. You want to kind of I don't know, expand the data out. So you get a lot of flexibility, but in general, we're working kind of record by record. Now, what was really cool that our retail giant wanted to use was our Spark evaluator. So most of our processors, you just configure them, and they perform operations like flattening field names and masking fields and so on. The Spark evaluator lets you run Spark code on those records in the pipeline. Okay, so you might have analyses, algorithms you've already developed. You might be training your machine learning model on this data as it's flowing through. And you can just drop this code into the pipeline as one of those processor boxes. So each batch of data is materialized as an RDD of these records, so just records with fields. And you can maintain state, you can save batches, you can perform reduces and shuffles, and you can even run these pipelines standalone, so that's what I do on my laptop, or within the cluster. So each pipeline in the cluster can be processing RDDs of records in parallel. So this Spark evaluator, it has a lifetime, basically as long as you run the pipeline. These pipelines, in contrast with the kind of batch operation of historic ETL, they're running continuously. Okay, so when a pipeline starts, your evaluator gets its Spark context and then receives each batch of data over time and gets to operate on those records with the standard Spark constructs. So I'll show you in a couple of minutes. I'll actually get down into some code. So you implement a piece of code. Your Spark app, basically you wrap it in this interface called a Spark transformer. that takes a batch of data, also some configuration data, and returns two RDDs. So you're returning the result records, and you can return error records. Okay? If you're doing some validation and something in this record is out of whack, you don't want to stop the whole pipeline and until we figure out what's going on. You can write these to the error RDD, and what happens is that StreamSets, the kind of the framework, will take those and send them along an alternative route. So if you can imagine, if your main stream of records is going to S3, maybe that error pipeline is going to a local file that you can examine and either reprocess them, or it turns out they're just junk. And you can even use tools like MLlib, an existing Spark code. So our retail giant was not actually using MLlib. They were using some other code that they'd written, but that way is certainly open. And I've done the classic faux pas of talking about the next slide. So yeah, your transform returns result records, error records, and we have this evaluator. It'll run on Cloudera and MapR. So this is actually running within the pipeline as a pipeline stage. Now, the other the thing that our retail giant customer was using this for was actually a bit of fraud detection and this real-time feedback and promotions that I mentioned before. But you can also use it for anomaly detection, sentiment analysis, all of these applications where you want to be in the stream of data and doing real-time processing. And again, this is the kind of processing that you want to be doing once. It's not the kind of interactive analysis that you do once it's in Hadoop or wherever you want to put it. In terms of connectivity, if you're running on the cluster, you can have any source you like as long as it's Kafka or MapR streams, because we basically use Spark's Kafka logic to run as many instances as there are Kafka partitions. Okay, so your concurrency is driven by your Kafka partitions, but you can write to the whole gamut of destinations. And this is not even the whole list, but I'm not going to read them all. Highlights that people use a lot are obviously Hadoop file system, HBase, not so much S3, see a lot of S3. Who's used Kudu? Okay, oh wow, hardly anybody. So Kudu's actually, it's Apache Kudu, it's a Cloudera product as well. And it's really nice because it's a mutable database that kind of falls between HBase and Parquet in terms of performance. So you get really good scan performance, not as good as just Parquet files, but really much better than HBase. But you can also change data in place, which you can't do with like Parquet files very easily. Anyway, Kudu, I'm a fan of Kudu, and a whole bunch of others. So Cassandra, Elasticsearch, et cetera, et cetera. And the other technology that our retail giant customer is using that is really neat is the executor technology. So I spoke about this a few slides ago. So in that slide where we're writing data to Hadoop, every time we close a file, we have to let Impala know. So we do that invalidate metadata. What we can also do is run a Spark executor to kick off a Spark application at a particular point in time. So typically, again, it's when you roll a file, you close a data set, you upload data to S3, it's time to fire off a batch process. So this is what we can do. So when we receive an event, and this is very abstract, so you can build this pipeline in many, many ways. So it's not just sending a file to Hadoop that could trigger this. But any event is received, you could kick off an arbitrary Spark application. So you say what the jar is, what the class is. You can provide configuration. And right now, we support Yarn and Databricks Cloud. So you can obviously send in the file name and so on. I'll show you some more interesting parameters in a minute. And with Databricks Cloud, who's used Databricks? A few people. So Databricks is pretty neat in that you can define these notebooks that you can work on iteratively and kind of develop your solution. And the Spark executor can run code either as uploaded Spark jars or in these notebook jobs. So this is really nice that we can kick off the job on a particular event, and we can pass in things like the S3 object key. Now, this really simplifies working, especially on Databricks, because we can upload a file to S3, kick off a Databricks job. So Databricks can mount S3 into its kind of local file system, and then it just works like Spark. So you can pass in the object name that you just wrote to S3, the object key. We can read the data in the Spark job, and we can use notebooks through, there's a widget API. So we basically use the Databricks REST API to send the parameters into the job and then just fire it off. And so this is really nice because we can do some experimentation. We can work iteratively. We can define a notebook, and if we're running data through this thing, we can maybe tweak it in real time between runs, save the new version of the notebook, and because we just say, okay, start this job with these parameters, with this notebook ID, then we'll just pick up the next version after you save it. So this is really nice for this kind of iterative development. You might be doing some experimentation. You want to kind of run data through and tweak it as you go. And in contrast to the stream processing, this is a more batch-oriented approach. You're putting a bunch of data in S3, and you're saying, OK, go process that now. So it's more useful for things like model creation, classification, other kind of batch analysis. All right, so this is where we go and see if everything's going to behave. So first of all, we have to come out of PowerPoint. And OK, so all right. So this is StreamSets. Each of this is an origin. It's just been configured with the location of some New York City taxi data. And what I'll do is I'll run a preview on here. So what I can do is just look at the first 10 records in my data set. And I can see that I don't know if anybody else has worked with this data. This is the New York City taxi data set. So there's a record per trip. And I think we added like bogus credit card details just to make it more interesting. So what we're doing is we're splitting out card from cash transactions based on an expression. So if the payment type field is card, then the records go along this path. Otherwise, they go along this one. So what's really cool is this is my Spark application. So how this is configured is, whoops. I've got this class, getCreditCardType. And what I'm wanting to do is from the card number, figure out the card issuing network. So it's all in configuration, OK? I don't want those issuing networks in the code because they might change over time. The numbers that are assigned to them might change over time. So I've got this configuration that I'm sending into my code, and in my actual Spark code, and I'm not going to talk through this because it'd be incredibly dull, but it boils down to, I'm using standard Spark constructs. I'm reading in the RDD of records here in this transform method. And then I'm down here, I'm saying, OK, if the credit card starts with this prefix, then set this field to the credit card issuer. So really, really simple stuff. This really isn't analysis at all. This is just a simple example that I can explain in 30 seconds. But what's really neat is we can actually see the processor doing its job here because we've fed the data through here. So we can see that this one's Visa because it starts with 4, and this one's MasterCard because it starts with 51. And then we want to mask the credit card numbers. I'm at capital 1. I have to get this all right, and then send it to S3. Now, if I actually run the job, so preview mode doesn't actually send any data anywhere. It just shows it to you, so you can kind of check the operation of the pipeline. If I run it now, what will happen is it'll read in, I think I've got about 5,000 records. There's a bit of latency in it starting up. And then it starts up just as I'm starting to sweat. Come on. Going to start now. Anyway, it's maybe just slow in updating the display. Anyway, it's reading in 5,000 records, writing them to S3. So if S3 is still alive, see if that's happened yet. OK, here's the one I did this morning anyway. And then what will happen is it'll kick off a job in Databricks. So as soon as that finishes, what will happen is it'll say to Databricks, OK, here's my S3 credentials to actually go and retrieve that. I don't want to put my S3 credentials in Databricks permanently. I just send them a job at a time. So over in Databricks, here's the one that successfully worked. Oh, I know what I did. OK, so this is actually a great demonstration of how StreamSets works. StreamSets maintains an offset into your data, so it never reprocesses it twice. So what I should have done is reset the origin, and then run it. OK, I want to wind that offset back to the beginning of the file. So what had happened was StreamSets, I'd run it before. The offset was sitting at the end of that file. So it was just sitting there waiting for another file to land in the directory that matched the wildcard and wasn't happening. Now there's 5,000 records. Now there should be a new record in a new object. Yes, there it is, 1151. Now there's a new object in S3. And now there's an active job in Databricks. And actually, we'll look at the previous one because that'll run for a minute or so. But the really nice thing here, so this is my notebook. So if you've used Zeppelin, it's pretty familiar kind of thing. So I'm mounting the data set there. And then what I'm doing here is very simple analysis. Again, it barely even justifies the term. I'm just getting the number of transactions per credit card type. So the kind of thing you can do in like one line of code here. And I'm also getting the average payment per credit card type. So I can see, oh, JCB has bigger transaction amounts, but on the other hand, there's only 13 transactions, so it's probably not very significant. But again, just a simple example to show you passing the data up, putting the data in S3, and then triggering this job in Databricks. All right, so let's try and keep things on track here. Come on, projector. I don't know why these things can't work faster. This is like the 21st century. OK, so wrapping things up. Spark is awesome for in-stream and end-of-batch processing. OK, all the hotness over the past few years has been around Spark streaming. But let's not forget that the batch operation is still alive and kicking. StreamSets Data Collector makes this in-stream processing really easy. The real important thing here is the decoupling of the data origin and destination from your Spark application. I mean, our retail giant was using multiple clouds and was able to just drop in additional destinations into their pipeline and not change the application in the slightest. Similarly, routine filtering code, filtering operations can be just factored out of that Spark code altogether and changed dynamically. This integration with Yarn and Databricks Cloud makes triggering batch processing like trivially easy. This is what our retail giant is using all the time. I mean, for production, you tend not to use notebook jobs. You tend to boil it down into a jar and run it from there. But it's exactly the same protocol. And this combination of StreamSets and notebooks makes it really easy to incrementally improve applications. So I ran the pipeline. Well, I actually ran it twice because the first time it didn't do anything. But I reset the data, ran it again. I could run that again, tweaking the notebook all day long, just to restart the pipeline and send the data through and really hone my analysis algorithm. A few resources for you before I go to questions. As I said, Data Collector is Apache 2 licensed, open source. We'd love for you to download it, try it out. We have customers who have put it into production and just happily using it without telling us or paying us, and that's fine. We have our open source community. We have a Slack channel and a Google group, and literally in the last week, we launched our Q&A website, Ask StreamSets. So, you know, it's my job to keep this community vibrant and expanding. So with that, I'll leave the resources slide up. And do we have a couple of minutes for questions? Oh, catch me! I've got a table outside, so you can catch me during the afternoon. I'll be here all day. Thank you.